Early in physics history, there was a huge debate over whether light was a particle or a wave. Newton believed that light was a particle due to its abilities of reflection and refraction, but one day Thomas Young came along and said it was a wave and he was going to prove it. His plan was the double slit experiment, in which a beam of light is shown onto a screen with two slits, and there's a third screen to see if there's any interference. If light was a wave, it would form an interference pattern by going through both slits. In an interference pattern, there's points of constructive interference where they add together, and points of destructive interference where the waves cancel each other out, and it would look like this.
And Young was right. This was the interference pattern that he saw on the screen.
So that's that. Light's a wave, end of story?
Not quite.
Later, scientists wanted to figure out exactly how light was behaving to form the interference pattern by placing an observer in the experiment to watch the slits. However, something bizarre happened. Under observation, light behaved purely as a particle, forming two clusters directly across from the slits. However, when the observer was taken away, it behaved once again as a wave.
This phenomenon is known as wave-particle duality, where light can act as a particle or a wave, just not both at the same time.
Is it just light or is it more than that?
Well, of course there has to be more than that.
In traditional physics, everything moving in a circle has something called centripetal acceleration, which is acceleration towards the center of the circle. So, in an atom, electrons circling the nucleus should accelerate towards the nucleus and destroy themselves. However, we know this is not what happened. Niels Bohr suggested that possibly electrons are only allowed to occupy certain orbitals of certain energy levels.
And Bohr was right. Electrons did exhibit this behavior, but no one could quite figure out why.
That is, until Louis de Broglie came along. He suggested that if light waves could have particle-like properties, then perhaps electron particles could have wave-like properties. He suggested thinking of electrons as a standing wave, similar to a guitar string. It oscillates back and forth, but it does not move in space. This was proven to be more than a theory by George Thomson, Clinton Davison, and Lester Germer. They shined a beam of electrons onto a piece of nickel, and if electrons were a particle, they would bounce back at the same angle. However, this is not what happened. When they shined the beam of electrons onto the nickel, they diffracted, which is a property of waves to spread out when they hit something.
So, if not only light displays
Wave.
particle duality, but so do electrons, and by proxy, all matter, and light and matter are how we experience the world. Light reflects off stuff, and that's how we see it, and matter makes up everything. Is it possible that humans stuck in our state as a perpetual observer are missing out on an entirely different way to experience the world with electrons in their wave state? And is it possible that with some future technology we'll be able to see this? Or maybe if I just turn around fast enough. It didn't work.